We're going to put it all together and talk about competition. We'll refresh the discussion of pure trade equilibrium that you guys did last quarter. Remind you about the Edgeworth Box, and then we'll talk about existence of equilibrium and how that relates to large economies. We'll then talk about production and how that lets us think about comparative advantage as a source of gains from trade. And then we'll talk about the winners and losers from international trade. Then I'll turn to comparative statics and stability. And I'll talk about how the basic properties of comparative statics that you're used to, like what's the effect of an increase in demand or supply, is related to the stability of a market equilibrium. And then finally, we'll turn to what I think is the most interesting part of the lecture, which is welfare theorems and their implications. And in particular, I'll try to persuade you that the first fundamental welfare theorem is really not pro-market at all. And then, in fact, in some ways, the second fundamental welfare theorem is like ultra-communistic. And that will help motivate why we'll be interested in all the things we'll be doing for the rest of the course. In particular, the role of information in determining the right trade-off between centralization and decentralization. OK, so let's go back to the pure exchange economy you guys studied last term. Is George He here? Hey, George. So why in a pure exchange economy are there gains that come from people trading intuitively?
Intuitively speaking, some people might be better at producing some products.
Well, in a pure exchange economy, that's not true, right? Right. The one you did last term, people just have endowments and they have preferences. Why are there gains from trade?
Then some people might have things that you don't, and you want to trade for them.
Mm-hmm.
And so, in doing so, you've increased your utility, and they increase their utility by getting stuff that you have.
Yeah. So the basic idea is I have things that you value more, or you have things that I value more. So there's like a heterogeneity in the ratio of marginal utilities to endowments, roughly, right? And allowing us to trade lets us each have more of what we value most. And the simple way to represent this was the Edgeworth Box, right? You had people with these different preferences, and they reached equilibria at points that where their indifference curves connected were below the point where the two curves were tangent, so that both could gain by trading. Here, the two individuals basically have the same preferences, but they might start with different endowments. Alternatively, they could have different endowments, but the same, different preferences, but the same endowments, and they could trade and make gains that way. So, you know, if we both have one apple and one orange, but one of us likes apples, the others like oranges, there's gains from trade there, right? OK. But not only do we know that there are gains from trade, we know two things about an equilibrium that you guys probably learned last term. One is that any equilibrium is proto-efficient. And the reason is that everyone has to set their marginal rate of substitution between any two goods equal to the market price, right? And this makes everybody's marginal indifference curves tangent to one another. And that means that we can't improve anyone's welfare without making anyone worse off. So you get that the ratio for any individual between their marginal utility of two goods has to be set equal to the marginal rate at which they can exchange those things for each other, which is the ratio of the prices. And that's equated across all individuals. Now remember that when we studied Lagrange multipliers, what those did was exactly the same thing. They forced that across any two inputs or any two uses of a resource, the ratio of marginal utilities was equal, right? And so you can really think of prices as just being for a society the same thing that a Lagrange multiplier is for an individual. It's forcing people, all different individuals, to take into account the same rate of trading off the value of different resources. OK. This is the invisible hand of the market economy that Adam Smith talked about. So the second thing that you guys probably learned was that any proto-efficient allocation is an equilibrium. all you need to do is transfer endowments from one person to another. Any efficient allocation is going to happen at some point of tangency. If you then put a line through that point of tangency, that represents the price vector that will support that equilibrium, right? Now today we're just going to reiterate many of these ideas, but instead in terms of production. So the simplest possible version is called the Robinson-Crusoe economy. And this is an island where the only thing there is to eat is coconuts, right? And coconuts can be produced really easily. For every unit of time you put in, you get a coconut. Everyone is the same on this island with a Cobb-Douglas utility function that is how many coconuts they get to the alpha times 1 minus how much they have to work to the 1 minus alpha, right? So they prefer leisure, but they also prefer being able to eat more coconuts. And we can introduce an arbitrary currency in this economy where labor is always worth $1, right? So we can just denominate everything in terms of the units of labor that something costs. So the firm produces 1 coconut for 1 unit of labor, and therefore for $1, because it has constant returns to scale, if there's a perfectly competitive set of firms, it's just going to supply coconuts for $1, right? Because it's got constant returns to scale, its marginal cost is just $1, right? Yeah, go ahead.
I'm just wondering, but if there are only 2 goods in this economy, namely coconuts and
Leisure, yeah.
why do we need prices if we're just going to present prices as one over the other?
Because you want to make sure that every person in the economy makes the same trade-off between leisure and coconut consumption, right? Because otherwise, that would be wasteful, right? So that's basically the role that prices serve. They serve the same role as a Lagrange multiplier. In every possible use of the resource, you make the same trade-off, the same opportunity cost of that resource. Okay, so Charlie, what's the equilibrium in the market for coconuts? What determines how many coconuts are going to be demanded in this economy?
It would just be determined by the alpha values.
Yeah, so how could we go about deriving that? So like if you've got a person and they can buy coconuts for $1, and they can work and get $1, how are they going to choose to maximize their utility?
Not sure.
Well, so the consumers have to choose how much to work, right? Their budget is that for every coconut they consume, they have to pay $1, right? And, sorry, I should have put times 1 minus L here. So, and then that has to be less than the amount of money they get from working, which is 1 minus L, right? So, where's Sang? Sang? Sang-Kyun? Oh, you're back there, yeah. So how does given this budget constraint, this should be times 1 minus L, how would the individual maximize their utility?
I don't quite understand what that.
Okay, so this should be 1 minus L here. So we know that 1 times the number of coconuts they eat has to be less than or equal to 1 times the amount that they work, 1 minus L. So given their utility function, how are they going to choose the number of hours that they're going to work? They're going to maximize their utility subject to their budget constraint, right?
Yes.
So what's the solution to that? This is their budget constraint, right?
I'm not following this.
Okay, so this is their budget constraint. They want to maximize their utility subject to this budget constraint. How do we do a constrained maximization problem?
Use Lagrange multiplier.
Yeah, and the constraint here is just that C is less than or equal to 1 minus L, right?
Yes.
So how do we, what's the solution? Would you ever want to consume fewer coconuts than the amount of work that you did? Would you ever want to leave money on the table?
No.
No. Okay, so then we know that C is just equal to 1 minus L, right?
Yes.
So you can just put in 1 minus L into that equation. Oh, sorry, L into, this should be L. I guess that's how much you work, sorry. This should be C is less than L, because L is how much you work, not how much leisure you take. So, so that should be L, so you take L to the alpha times 1 minus L to the 1 minus alpha. What's the maximum of that? How do you maximize that?
Do a differentiation and
Yeah. So do you could do that on the board, or you could tell us if you can do it in your place, whatever you want to do. What do you get?
so you get like C is alpha and L is 1 minus alpha. It depends on the alpha.
That sounds right. So if we take the derivative of this with respect to L, right, we get that L alpha times L to the alpha minus 1 times 1 minus L to the 1 minus alpha over is equal to 0. Oh, sorry, minus 1 minus alpha times 1 minus L to the negative alpha is equal to 0. So let me put that up on the board. Okay, so that gives us that 1 minus alpha over alpha is equal to L to the negative 1 and times 1 minus L. So the ratio of 1 minus L to L is alpha over 1 minus alpha, right? And so if the worker has, 1 hour, 1 unit of time, right, then we know that C plus L has to be equal. Yeah, this is a little bit messed up. I'm sorry, this should be 1 minus L here. Has to be that, so if we have L, 1 minus L over L is